Okay. Okay. Greetings to all the great trolls. So thank you for following us. I'm going to present a class on sketching of functions, specifically focusing on sketching a logarithmic function. So by the end of this section, you guys are supposed to be able to sketch um, a log function. The previous class, we were sketching an exponential function, and we know that there is a special relationship between the exponential function and the logarithmic function. And we said a logarithmic function is the inverse of an exponential function, and the inverse of an exponential function is the logarithmic function, or vice versa. Okay, thank you so much. I'm going to look at this section. I'm going to look at this short section. If you manage to sketch a logarithmic function, an exponential function, then a logarithmic function should not be a problem to you. Okay, right. Let me take you to the board, and let's try to do this together. Now, look at this. Look at this. Let's go to the board. Now, if your board that features just like any other graph. So I'm going to look at the logarithmic um, all right, logarithmic graph. Right. In terms of equal to a log, sorry, um, log b x minus p. Okay, it's supposed to be b there. Sorry, plus. Probably if I can allow me to present it again. Sorry about that mistake. This is y equal to a log p plus a q. This is base b, something like that. That's a logarithmic function. Okay, right. Its important features. What are the important features? Important features. Just like an exponential function, I'm going to start with the shape. Right. The shape of a logarithmic function is determined by the base. Okay. Right. If is greater than 1, then a log function is generally increasing. Look at how your logarithmic function is going to increase. Okay. Right. If the base is between 0 and 1, then the logarithmic function is going to decrease. Right, look at that. That's how a logarithmic function decreases. Okay, meaning to say, if I've got something like y equal to log x base 2, the function will be increasing like that. And if I've got a function like y equal to log x base a half, and it's going to what? Decrease like that. Okay, right. The next thing are the intercepts. Just like any other function, you also need to know where the graph is going to cut the x-axis and the y-axis. X equal to 0, and y intercept x is equal to what? 0. From there, we've got an on a log function, and that is what? A vertical asymptote. On an exponential function, where the what? Where the horizontal asymptote. In this one, there is a vertical asymptote, which is going to be given by what? x minus a p equal to 0. In other words, that part which is in the bracket, you take it, you equate it what? 0. Okay, something of that sort. Allow me to remove this. Okay, right, now there you go. Minus p equal to what? 0. Right, then you solve for x, that would be equal to that. That's how you come in exponential, the vertical asymptote of a logarithmic function. From there, it is also important to note that you should be able to come up with the domain and the range, right? If you look at the domain, right? The domain of this is what? Okay, I've got two sets. There's generally increasing one, or there's also decreasing one. All right, and if you are looking at the domain of this, you can see that the domain x greater than. Okay, this is the line x, which is y-axis, the line x equal to 0 line, which is the same as the y-axis, something like that. So the graph starts at slightly after x equal to 1 to positive infinity, right? Then I'm also going to look at what we call the range of an exponential function. Remember, if you look at these functions, you can also see that if I've got something which is increasing, the domain, this is where this graph starts, ends along the y-axis. So the range to this, it means y is an element of all real numbers. The same goes if this was to be a decreasing function on the range to negative infinity, starting going up to positive infinity, something like that. So range of logarithmic function is supposed to be from negative infinity to infinity. Okay, right. Let's try and look at something of this sort. Right, just quick examples there. Just quick examples there. Right. I want us to look at an example to this. Just a quick example to this. Right. If you look at this, I'm going to take this as my example number 1. Okay. Example number 1. We are trying to sketch the function f of x equal to log x minus a 1 base 2. Okay, I'm trying to sketch this. I'm going to say first shape like, and the shape is determined by b. In this case, the base is 2, so it means it's greater than what? 1. So this is basically a generally increasing logarithmic function. Okay, I'll calculate the intercept, x-intercept, y is equal to 0. So I'll take the function y is equal to log x minus 1 base what? 2. But y is 0, so this is 0 equal to log x minus 1 base of 2. I'm solving for x, so I'm going to convert from logarithmic form to exponential form. This is the number, this is the base, and this is the logarithm or the exponent. So I'm going to say what? X minus 1 is equal to 2 to the power of what? 0. So it means it's x minus a 1 equal to 1. This is x equal to 1 plus 1, and your x is equal. So that passes through 2 and 0. Okay, right. From there, you can also choose to calculate y equal to what? We can call this the y-intercept, where x is equal to what? 0. And you can see that this is y equal to log 0 minus 1 base 2. And this is going to be log of negative 1 base 2. And we said from the definition of a logarithm, the logarithm of a negative number does not exist. X is always supposed to be greater than what? 0. So I can say no y intercept, meaning to say this graph will never touch the y axis. Okay, right. So no y-intercept. Then from there's one asymptote, which is the vertical asymptote. Now, with your vertical asymptote, I can safely say what? With my vertical asymptote, this is going to be x minus 1. That part which is in the bracket equated to 0, which is equal to what? 1. So that is your vertical asymptote. I'm now sketching this graph. Allow me to sketch this graph. I'm going to say, there you go. There you go. Right. Start with an asymptote. Remember, whenever I've got a graph with an asymptote, you're supposed to start by inserting your asymptote, which is x equal to 1, the vertical asymptote there. Then it passes through 2, something like that. Then from there, I know that this is going to be generally increasing. So it's going to start from the bottom, going up, right up to the, there you go. You can label it f of x. That is the drawn graph. This is y, this is x, right? Someone can also choose to come up with this domain and its range. What is the domain of this graph? This graph starts right after x equal to 1 to positive infinity, which means this is greater than 1. What about its range? From negative infinity right up to what? Positive infinity. So it's y element of all real numbers. Okay, that was for f of x drawn. What about f inverse? Without even drawing it, you know, that which restricts the x on the domain restricts on the range. That which restricts y, the range on f of x is now the restriction for your x on the inverse. Okay, that's very important. You should always know how to play around with. We get another example on this. Um, example number 2. Okay, let's look at your example number 2. Right, on my example number 2, right, on my example number 2, the graph, sketch the function, what, f of x, which is equal to log x base of a quarter, something like that. Examiner says just sketch this. All right, I'm going to say shape. What is going to be shape? If you look at the shape, is between 0 and 1. So this is going to be generally decreasing, and the logarithmic graph decreases like that. Okay, I'll calculate the intercept, x-intercept, y is equal to 0. This is going to be y equal to log what, x base of a quarter, right? But y is 0, so this is 0 log x base a quarter, which is what? Change this to exponential. It means x is equal to a quarter to the power of a 0, which is x is equal to 1. Since this is a basic function, all function of that family or of that sort, basic function, they always pass through 1 and 0. What about the y-intercept? We know that x is also equal to what? 0. So I can now come in and say y is equal to log 0 base a quarter. And log of 0 does not exist, so there is no y-intercept to the graph. Okay, now I'm now getting the vertical asymptote. The vertical asymptote, it means x is equal to what? 0. That's your vertical asymptote. Right. I can sketch this now. This is one basic graph that you can without even calculating all the important features. Okay, right. I'm going to start with the asymptote as usual. This is the x equal to 0 line. So you can label it x equal to 0 line, the y-axis. Okay, then it passes through 1 and 0, 1 and 0. I'm going to be guided by the shape that's generally decreasing. With just that point and the asymptote, one should be able to sketch it. So it means it generally decreases right down. That is the log function, okay, which is generally decreasing. That is the log function. Unfortunately, my graph is not coming out clearly. Let me just draw it. Let me just put it up there so you can see what we are talking about. Okay, sorry about that. There you go. There you go. Okay. We said it's going to be passing through 1 like that from our calculations 1 at 0, and this is generally decreasing. So it starts from the top, it decreasing, going out, something like that. This is the x-axis, this is the y-axis. Fine, let's look for the domain of this thing. The domain, you can all see that domain, this is what, x greater than what, a 0. What is going to be the range? The range of this graph, it is y element of all real numbers from negative infinity. That is, if you look at the bottom part, it goes towards what, negative infinity, and the top part, it goes towards positive infinity. So it's from negative infinity right up to positive infinity, which means what, x is an element of all real numbers x. What about for f inverse? I'll come and say domain and I'll say range there. So this will be all real numbers, and this will be y greater than 1, 0. Okay, that's the most important thing there. That is basically sketching your logarithmic function. Okay, I can also give you another example. Let me just look at probably one more where I'm going to draw this thing with yet another graph, say a parabola. Okay, that will be it on sketching the functions. Okay, right. Let's look at last example on this one. Let's look at the last example on this one. Okay, right. Sketching. Okay, sketching. Or let me just say sketch the following functions. Sketch the following functions on the same set of axes. On the same set of axes, I've got what? F of x, and my f of x is given by log what? This is x plus a 1, and that is base a third. And what? G of x is actually equal to my g of x, it is something like this. It's a parabola, which is 2 in bracket x uh, plus 2 whole squared minus oh, that is minus. Okay, let me just give you something with a plus there. Then that will be plus, say, 4. Right. Now let's try to sketch this on the same set of axes. Right, my logarithmic function. I'll start with its shape. Right. The shape, you can see that the base lies between 0 and 1. So the function is going to be generally decreasing. That's how a logarithmic function decreases. I'm going to look at the x-intercept. Y is equal to 0. So I'm going to come and say 0 is equal to log what? X plus a 1 base a third. Right, with that, remember it's in brackets. From there, I'm going to say changed from logarithm to exponential. So it means this will be x plus 1, a third to the power of that, which is x plus 1 equal to 1. So it's x equal to 1 minus 1. Your x is equal to 0. So that passes through 0 and 0. You can also calculate the what? The y-intercept. Calculate the what? The y-intercept where x is said to be 0 now. So it means this is going to be y is equal to log what? 0 plus 1. Remember that's in bracket to the power of a third. And if you look at this, this is log 1 base a third. Any logarithm of 1 base um, any number, it means that is going to be what? 1. So this is going to be 0. Okay, so it means it also passes through 0 and 0, something like that. All right, so that's log of a third, that will be equal to what? Is 0. Okay, right. Sorry about those that were not visible. Right. I can say that is that. Then on your vertical asymptote, you can come and say the vertical asymptote of this is going to be x plus a 1 equal to what? 0, which is what? X is equal to negative 1. That's a vertical asymptote. So I now have coordinates there. The y-intercept is 0 and 0. The x-intercept is 0 and 0. Something like that. Okay, so I can now come and sketch this graph. If I'm to sketch this graph, allow me to do it somewhere there. All right, allow me to sketch there. Okay, if I am to sketch this, I'm going to say start with the asymptote, which is x equal to negative 1. X is equal to negative 1, right? Then from there, this passes through 0 and 0 both. Once a graph passes through the origin, it means it cuts the x-axis and the y-axis at the same time, and this is generally decreasing. So it starts from the asymptote, it decreases, it passes through 0 and 0 going out, right? This will be what? Your f of x drawn. I'll now come to my parabola. If I'm to look at my parabola, I'm going to say this is basically y equal to 2 in bracket x plus a 1 whole squared plus a 4. Right. Now this will then be first the shape. What is going to be your shape? A is greater than 0, so it's cup shape. Okay. I'm going to calculate the y-intercept. X is equal to what? 0. So it means y-intercept in this case, this is y is equal to what? 2 in bracket 0 plus 1 all squared plus a 4, which is 2 times a 1 plus 4. That should be a 6. Right, I'm sure that should not give you a problem. Good. Right, I'm now looking at the x-intercept. The x-intercept y is the one which is now 0. So it means this is now 0 in bracket 2, what? X plus a 1 all squared plus a 4. This will come over as negative 4 equal to 2 in bracket 1 plus that all squared plus a 4. Right, but the 4 is gone the other side, transposed already. Divide both sides by 2, that would be negative 2 equal to x plus a 1 all squared. I'll get the square root of both sides. Right, and in that case, you can see that this is the left hand side is now square root of a negative number. So it means there is no intercept. Okay, if there's no x-intercept, the next thing is to get the turning point. How do I get the turning point? The expression is already in completed square form. So it means the turning point becomes minus 1, 4. If you look at that expression, that is y. If I can just use that side space, y is equal to 2 x plus 1 all squared plus a 4. I'm going to say this is in bracket x minus minus 1 all squared plus a 4 right? Something like that. So it means my P in that case is -1, and my Q is going to be what? +4. So it means the turning point is -1 and 4. Right. I'm now sketching that. Remember, look at this graph. This is going to be um, passing through 6. You can see that. Where is your graph? 0 and 6. 0 and 6. I'll come in level 6 there. Right. Then the x-intercept, the graph is not touching the x-axis. Okay, where is it turning? It turns at -1 and 4. So I'll come and say -1 and 4 is somewhere there. Okay, right. Now from there, that's all we have. So I'm going to sketch this with only two coordinates, one there and one there. But I know that this is going to be cup shaped. So if it's cup shaped, so that it turns right. That will be your bell-shaped parabola, and that coordinate is -1, 4, something like that. That's your parabola. With this one is 6. Right, I've managed to draw two graphs on the same set of axes, which is uh, a logarithmic function and a parabola, something like that. Okay, so that's how you basically sketch your logarithmic function. I just took time to review with you how to sketch a parabola. Okay, right. That's profound. That's very, very important. Stage is grade 12 expected to be very, very, very swift in doing that. Very important for one to be able to sketch function with you. We sketched a parabola. We can now sketch a hyperbolic function, whether in general form or in standard form. We looked at the sketching of exponential function. Now the last one was basically for us to be able to sketch logarithmic function. Okay, thank you so much. Hope you find practice, practice. That's the name of the game. Be giving you as many problems as possible, typical examination questions. Following us, we are going to develop more and more concept that stretches and covers the whole of your